Hi friends, let's solve this physics problem. It says a wave has an angular frequency of 110 radian per second and a wavelength of 1.8 meters. So we should calculate the angular wave number and the speed of the wave. And so I have, let me minimize this. It appears big. So the general equation of wave is, we assume it's a transverse wave. So we have y equals ym sine kx minus omega t. Now we try and define, this is displacement. This y is called displacement. That as the wave travels along, this is displacement. Displacement. So ym is the amplitude, y subscript amplitude. Okay, k is wave number, which we are required to calculate the angular wave number. Angular wave number. X is the position of the particles of the wave that vibrate at a given time. Position. Omega is angular frequency. While t is time. Now kx minus omega t is, we call it the phase. Of course, the phase change, just the phase, while the totality of sine kx minus omega t is the oscillating term, and so it's responsible for the oscillation. This is the sine function. Of course, the sine function repeats itself after 2 pi, that is 360 degrees. Pi radian is 180, pi 2 pi is 360. Okay. Now when we say phase change, kx minus omega t, if you have two successive waves, for instance, one travels and the second one goes like this. So this difference, what we call phase change. This is kx minus omega t. So that is the phase change, or the phase difference. Okay. Now what we now do is I'll wipe this. I hope you understand it. Now for matter of space, we use this. Now what we now assume solution to A. Okay, let's assume that there is no phase difference. What it means is that kx minus omega t equals 0. No phase difference. And of course, this is omega is 2 pi over t. The reason is it has to be a distance in radian for one complete oscillation. So the wave has to travel, the oscillating particle has to travel from 0, when theta is 0 radian, to when theta is 360. This is complete oscillation. So it's 2 pi divided by the time it has taken the particle to traverse this space. So this is it, okay? Now we have k. If we substitute, call here 1, call here 2. We substitute 2 in 1, we have k x equals 2 pi t times t. Okay, kx gives us 2 pi. Okay, but at this point, this is complete oscillation. The distance from this point to when the particle has completed with oscillation has to be its wavelength. We know crest to crest is one wavelength, or trough to trough, trough to one wavelength. Also from this point to this point is also one wavelength. And so at 2 pi, angular displacement of 2 pi, s changes to its wavelength. This is 2 pi. So that gives us angular wave number to be 2 pi over lambda. Now from the question, lambda is 1.8. Of course, we know what pi is. Pi is 222 over 7 or 3 pi 1/4. That's 3 pi is 3.14. Okay. So when we do that, we have 2 times 3.14 all over 1.8. Okay, so that gives us k equals 6.14 all over 6.28, sorry, all over 1.8. Okay, let me just approximate this to the nearest whole numbers. This is 6 over 2, since I have no calculator. So k is 3. What is the wavelength? What is the unit? Recall that k is 2 pi is a constant. 2 is a constant, pi is a constant. Lambda has this unit as meter, so it's 3 per meter. Okay, that is for the angular wave number. Now, what about the speed of the wave? I will have to wipe here while I leave our equation. Wave equation. Now, again, we assume that if we assume that the phase B, to solve B, we assume that the phase difference kx minus omega t is a constant k. Okay, so that if I want this to be 0, the constant to be 0, I differentiate both sides of the equation. I will have the kx equals the omega t. So omega is constant, k is constant, k is a number. So we have k dx equals omega dt. So we have the x dt equals omega over k. So this is v. Okay, of course, you know, with how we call group velocity, vg, is also the omega dk. Okay, but that's what we're talking about now. Okay, so omega we know is 110. Now we calculated k to be 3. So that is a 3 into 11 is 3. I remember 2 into 20 is 6. Remember 2, 6. Okay, let's say 6.7 meter per second. I hope this helps someone. Thank you very much, friends.